Hong Kong, as the fourth most densely populated city, requires significant demand in energy, as it is needed in every aspect of life, from infrastructure to personal entertainment, from home to work. In 2015, Hong Kong has set the target of reducing energy intensity by 40% by 2025, using 2005 as the base. Buildings account for 90% of total electricity consumption in Hong Kong, and among various electricity uses, HVAC systems consumes the most, around 30%. To achieve the reduction target, the most direct method is to reduce the energy use by HVAC systems in buildings. However, HVAC systems are essential for most of the buildings. HVAC systems ensure indoor air quality by heating, ventilation and air conditioning, providing a safe and comfortable indoor environment to the public. Therefore, on the premise of ensuring a safe and comfortable indoor environment, the energy saving of the HVAC system can only be achieved by enhancing the energy efficiency of the system. Chiller plant is a core component of HVAC systems, and it produces chilled water for cooling the buildings. A chiller mainly consists of four main components: compressor, evaporator, condenser, and expansion valve. For buildings with large areas and number of occupants, multiple chillers are usually installed in order to achieve the desired cooling demand. In recent years, variable speed drive (VSD) was developed. Chillers equipped with VSD drives have higher efficiency than conventional chillers, especially in part load conditions. VSDs are installed to the compressors in the chillers. Electrical power is delivered from the supply to the VSD and then sent to the compressor. VSDs regulate the frequency and voltage of the electrical power. The speed of the compressor is adjusted according to the building cooling demand. Together with EMSD and Hospital Authority, we had conducted energy, cost and carbon emission saving analysis on 12 chiller plants in Hong Kong with total cooling capacity of 8,500 refrigeration ton. The results showed that up to 40% of electricity consumption can be reduced by replacing existing conventional chillers to VSD chillers, which is equal to an annual energy saving of 12,000 megawatt hours. The annual cost saving is more than 13 million Hong Kong dollars, and the annual carbon emission is reduced by 7,000 tons. This equals to planting 43,800 trees per year. It was also found that the average simple payback period of replacing the VSD chillers was a year and 7 months, which is very short comparing to the normal lifespan of 15 years for a chiller. After a period of use, there will be a certain gap of the performance of the entire chiller plant between the actual data and the design values. The design values cannot accurately predict the actual performance of the chiller plant in the complex and changing operation environment. In order to optimize the actual performance of the entire chiller plant more accurately in real time, big data analysis of actual performance data was conducted to develop a predictive operational control strategy by fully considering the characteristics of VSD chiller plants. To take the advantage of advanced computational algorithm, artificial intelligence, AI, is employed as data mining algorithm, with big data analysis based on the actual acquired performance data to further improve the performance of chiller plants without any additional equipment installation. Artificial neural network (ANN) models are adopted to predict the building cooling load demand and power consumption of individual chillers. Real-time data are received from Central Control and Monitoring System (CCMS). Through the predictive model, the efficiency of individual chillers and the overall electricity consumption in the whole possible range of set points in the future can be found. By comparing all feasible operation combinations, the optimal control options with least power consumption can be selected, and the information will then be submitted to CCMS for actual adaptation. This real-time, continuous, reliable, automated optimization control strategy can determine the most efficient combination of chillers and pumps with different control settings. This ensures that the chiller plant is operating in its most efficient state year-round, regardless of load, and as well consider the real-time weather condition. Computational simulation on the predictive operational control strategy have been conducted. By using this advanced control strategy, an additional 10% to 13% saving of energy consumption could be achieved without any additional equipment installation. The annual power consumption saving is projected to be up to 500 kilowatt-hour per refrigeration ton. Using AI and advanced chiller technologies in new installation and replacement of existing chiller, the energy consumption and the overall cost of system operation can be significantly reduced. This will benefit the building owners with reduced cost, engineers with faster and simpler system diagnosis, and occupants with more comfort indoor environment. For the future of Hong Kong and the whole world, not only government policy is needed for energy saving, but also in how businesses operate and how individuals live. We wish to work with building owners, engineers, developers, investors and public to promote green buildings in Hong Kong and achieve energy saving targets alongside environmental and financial goals.